Welcome to this explainer. Today, we're going to completely demystify the hidden mechanical magic of a car's clutch. You know, if you've ever driven a manual transmission, you've interacted with this system literally thousands of times. But have you ever stopped to think about what's actually happening down there under the floorboards? Well, together, we're going to transform what is basically just a list of car parts into a really dynamic story of cause and effect. We're going to uncover exactly how a seemingly basic foot pedal gives you total, uninterrupted control over a massive, powerful machine. Let's get into it.
Okay, so let's kick this off by thinking about a really fundamental problem every single vehicle faces. Your car's engine? It is designed to spin continuously. Basically, as long as it's running, it is turning. But your wheels, well, they obviously need to stop at red lights, they need to pause, and they absolutely have to change speeds independently of how fast the engine itself is working. Think about it. If the engine was permanently glued to your wheels, your car would stall out and die every single time you hit the brakes. No way around it. So how do we actually solve this?
Here's how we're going to break this down today. First, why cars need a clutch. Second, the anatomy of a clutch. Third, how the clutch works. And fourth, the art of smooth shifting. Starting with Section 1, why cars need a clutch and how we solve the problem of a continuously spinning engine. I want you to think of the clutch as the ultimate mechanical handshake, or a bridge, really. By definition, a clutch is a mechanical device that connects and disconnects the engine from the gearbox. And it's exactly that ability, the power to instantly interrupt the flow of energy, that lets a driver change gears smoothly or bring the whole vehicle to a complete stop without killing the engine. It is, quite literally, the gatekeeper of your car's power.
Moving right along to Section 2, the anatomy of a clutch. Let's meet the physical cast of characters hiding under your floorboards.
First up in our lineup, we have the flywheel. Now think of this as the foundation. The flywheel is bolted right onto the engine's crankshaft. What that means is, if the engine is running, the flywheel is constantly spinning right along with it. And its main job? It provides a nice, flat, sturdy friction surface for the rest of our components to grab onto.
Next up is the clutch disc, which you might also hear called the driven plate. This is the vital component, the absolute star of the show that actually receives the engine's spinning power and transfers it straight down the line to the transmission. It basically just sits right there next to the flywheel, waiting to be engaged so it can pass that rotational energy onto your gearbox.
And then there's the pressure plate. Honestly, you can think of this piece as the enforcer of the group. Its one and only job is to firmly and securely hold that clutch disc right up against the spinning flywheel. When the pressure plate is doing its job correctly, the flywheel, the clutch disc, and the pressure plate are all locked together, spinning as one solid heavy unit.
Finally, we've got the control chain. This is the mechanical sequence that actually connects your foot to all that action. It obviously starts with the clutch pedal. Your foot presses the pedal, and that movement travels through either a hydraulic system, using master and slave cylinders, or a physical cable. That energy pushes the clutch fork, and then the fork shoves the release bearing, also called a throwout bearing, directly against the fingers of the pressure plate. It's an incredible little chain reaction.
Section 3. How the clutch works. Let's actually put all these pieces into motion.
Now, this right here is the wildly counterintuitive heart of the whole system. When we say the clutch is engaged, it actually means your foot is completely off the pedal. In that state, the pressure plate is actively clamping the disc to the flywheel, and engine power is flowing perfectly to the gearbox. But when the clutch is disengaged, meaning you've pushed the pedal all the way down to the floor, you're actually unclamping the disc and totally disconnecting the engine power. Pressing down equals disconnecting. Crazy, right?
So here is the exact step-by-step chain reaction. The split second your foot hits that pedal, step 1, the release bearing moves forward. Step 2, it pushes aggressively against the pressure plate fingers. Step 3, all that mechanical leverage forces the pressure plate to literally pull away from the clutch disc, which causes Step 4, the clutch disc is immediately unclamped and freed from that spinning flywheel.
And just like that, boom, power is disconnected. Since the clutch disc is no longer being squeezed against the flywheel, it instantly stops taking in rotational energy from the engine. This temporary pause, this brief disconnection of power from the gearbox, is the magical moment. It's exactly what stops your car from stalling at a red light, and it's the only way you can safely and smoothly slide your shifter into a new gear.
Which brings us to our final section, number 4, the art of smooth shifting and how we re-engage that power smoothly.
So, bringing the power back online requires a bit of finesse. Step 1. You, the driver, have to slowly let off the pedal. As you do that, step 2 kicks in. The pressure plate gradually starts to clamp back down on the clutch disc, easing it against the spinning flywheel. Because you're doing it progressively, we get step 3. Power is transferred smoothly back to the transmission. It's this controlled, gradual friction that prevents the car from jerking violently and lets you glide away from a stop sign.
When we pull back and look at the whole picture, it is just incredible how much work this one ingenious little mechanism does. I mean, it's juggling 5 crucial functions. It connects and disconnects the engine's power. It allows for smooth gear changes. It completely prevents the engine from stalling when you stop. It lets you ease smoothly off the starting line. And it absorbs harsh shock loads that would absolutely shred your transmission otherwise. It really does it all.
It's honestly fascinating, isn't it? Just a simple press of your foot orchestrates this massive, complex separation of heavy spinning metal, giving you complete, effortless control over the entire machine. So let me leave you with this. The very next time you hop in a manual and press that pedal down, are you going to feel it? Will you be able to visualize that release bearing pushing those pressure plate fingers? Will you actually feel that mechanical handshake happening right beneath your feet? I really hope this explainer gave you a brand new appreciation for the hidden engineering making your daily drive possible. Thanks for hanging out, keep learning, and enjoy the ride.